Assalamualaikum warahmatullahi wabarakatuh. Today I will teach you a random variable. Now you can refer to books known as a Sham series. You can refer to books known as Shams. This is a random variable. And you can refer to books as known as a Sham series, chapter 2, chapter 2, page 38, These the notes here, the books here. You can these are week 3 lecture notes. Okay, week 3. So now when you look at the definition of, by definition, the random variable is known as a random variable is a single value real function. It's a real function. So talking about, let's say I have here, let's say I have talking about domain. We have a domain here. Domain. Let's say I have a domain here. I have a domain, and I have a range. Okay. The connection between domain and range is known as the random variable. Or random variable function. The connection between the domain and range is known as a random variable function. So let's say I have a domain here, indicate as a sample space here, and here inside here you have eta, for example, you have zeta, and then it connects with the real line here. Here is the real line, up to here is R. Let's say in the sample space here, I have eta here. Eta represented by let's say I have head and tail. Okay, head and tail. Okay, if I have head here, the range for head is equal to, let's say, head refer to 1 and tail is referred to 0. And the connection here is known as a function of x. So we can write here x of zeta is equal to, let's say I have zeta is equal to h, or head, as h is equal to 1. And this connection, or this function here, or the connection, is known as a random variable function. And now if I have x tail is equal to 0. Okay. These are the definition of what we call the random variable function. Okay. Now if we refer to the notes here by Sham series here, so he puts here now the connection between the sample space here. This is a sample space, and sample space is a zeta here, and the connection between this one and the real line here is known as a range here, and this connection is known as a random variable function. In other words, a random variable of x zeta, is a single variable real function. Function here is indicated as x that assign a real number called a value of x zeta. Here is it's a real number. Assign real number. Now, for each sample point zeta of x. So this we have a sample space here, a sample point here, h and t, and this sample point h and t is assigned as a real number or real value. The real value here is h is referred to, t is referred to 0, and h is referred to 1, and this thing is known as a random variable. So in other words, x of t is equal to 0 and x of h is equal to 1. Now another example, if we look at the example here, example 2.1. Now in the experiment of tossing a coin once, we might define the random variable as below. So if I have a coin here, so tossing a coin, let's say we have coin here. The coin can either be head or tail. The coin can be either head or tail. So let's say I have a coin here. Coin can be head or tail. So if you toss a coin here, you can either get head or you can get tail. So these are sample space of tossing a coin. So let's say if I get a head, I define as I give a value of 1, and if I got the tail, I give a value of 0. So the random variable function is equal to x of h is equal to 1 and x of tail is equal to 0. There's several ways how we can write the random variables. So you can write like this: x is equal to x. Okay, x is equal to x. You can write like this: x is equal to x. You can write as x is equal to x. Zeta is represent zeta, x zeta is equal to x, or you can write like this: capital X is less than x equal to x zeta, x zeta less equal to x, or x greater than x. So zeta represent x zeta greater than x, and x in between x1 and less than equal to x2. Zeta x1 less than zeta x less than equal to x2. These are how we write, the other way to writing the random variables. Okay. Now, let's say I have another experiment. Let's say I have an experiment of tossing a coin have an experiment of tossing a coin twice. Okay. Now we are tossing a coin experiment here. The experiment here is tossing a coin. The experiment. So every property we need to have an experiment. So the experiment here is tossing a coin. Tossing a coin twice. So the sample space here is equal to, so you can either get the first one, you can either get head or tail. These are first experiment, first outcome. Then you can either get the second toss, you can get from head, you can get either head, or then you can get tail. Here also you can get head or tail. So the sample point here now the sample point here is you have head, and you have head and tail. Then you have here tail and head. Then you have here tail and tail. Okay. So the sample point here is equal to, you can get head, you can get head or tail, you can get tail, head, or you can get tail and tail. Okay. So let's say I define my definition here. My definition is getting of head, tossing a coin twice, tossing a coin twice. So I want to have the result of getting, the outcome is getting a head, So this is my definition. So now so you can either get two head here. So your range here is you can either get two head, you can get one head or no head or tail. So if we draw in terms of the line here, the domain and the here is your domain, and here is your range. So if I draw in terms of the domain and range, so we can have like this. As here is our domain here. We have head and head, we have head, then we have head, tail, then you have tail, head, then you have tail, for example. So this is a sample space, or in other words, this point, all this point is known as a zeta. Okay, so I want to connect this zeta with the real line or the range. Here is a domain. This is a domain, and I want to relate with the range here. Okay, the real line R. In other words, here is your range. Okay, so you can either get zero head. Here is zero head. This is zero head. Then we can get one head. This refer to one head. This is one head. These are one head, one head. Or we can have two head. Here is two head. Then yeah. So here is, I cancel this one. Cancel this one. Okay. Now the range here is like this. We can have no head. Here is referred no head, zero head, and here is referred to one head. Head, tail head is one head here. Here is referred to one head. Or then here is also referred to one head. Okay, one head. Then you can have two head. Two head will refer to this part. This part is two head. Refer to two head here. Okay. So this is the sample space, this domain, and here is the range. So in other words, the function here is known as x. So x of x of t and t is equal to 0. X of ht and th is equal to 1, and x of h and h is equal to 2. So this is known as a random variable. This part is a function. It's a connection between the domain and the range here, the real line here. The connection between the domain and the real line here is known as the what you call the random variable. Now, if I want to find the probability here, what is the probability of getting the probability of let's say I want to let's say I have tossing a coin 3 times. Okay? So let's say I have an experiment of tossing a coin 3 times. Experiment here. My experiment here is tossing a coin. My experiment is experiment tossing a coin 3 times. So the possible outcome is you can either get the first outcome is you can get either head or tail. Then from here you can get either head or tail. Here you can get either head or tail. This is the first experiment. This is the second. The third one you can get either here is head or tail. This one also you can get head or tail. This part you can get head or tail. and here you can get head or tail. This is a third experiment, third outcome. So can be written as, you can have here sample space H, H, H. You can have here H, H, T, H, H, T. Then you can have H, T, H, H, T, H, H, T, H, H, T, T, H, T, T. And we can have T, T, H, H, T, H, H. Then you can have T, H, T, T, H, T. Then you have T, T, H, T, T, H. Then you have T, 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 T. Okay. Now this is a sample space. And inside here, the value here is known as the element here. This is known as elements. The elements here is referred to zeta. Okay. So I want to here. So let's say the name of experiment here is tossing a coin 3 times and getting a head. So getting head. So you can either get 3 head. You can get 3 head, or you have 2 head, or you can have 1 head, or you can have 0 head. So the range here, this is your range. Okay? This is your range. The range can be 0. So normally we put in the ascending order. So you can write here as a 0, 1, 2, and 3. So I write here 0, 1, 2, and 3 in ascending order. You can get either 0 head, no head, all tail, 1 head. So 1 head is referred to this one. Okay, 1 head. This is also 1 head. And you can get either 2 head. 2 heads refer to this one, and this one. This is 2 head. Okay, 2 head. Or you can have 3 head. This one. So we have put here my domain here. S is a domain. This is a domain. This is a domain. This is a domain. Yeah, this is a domain. And here is your range. Okay, range. So if I want to find the x of all head, head is equal to 1. X of all tail, 10. Or 0 head is equal to 0. Okay. Now x of the function of 2 head. So I have here head, and t. Then h, t, h. Then you have t, h, h. This refer to this equal to, I have 3 here. And if I draw a function of 1 head, so I have one. This one is a HHT, HTH, THH. So for 1 head, so 1 head is equal to HTT, T, then THT, and then you have THT, TTH. So you can also have this is equal to 3. So all head means all head means 3 head. All head means 3 head. So 3 head is equal to here is all head means 3 head. Sorry, this wrong. This wrong. Okay, I just cancel this one. All head means 3 head. Here is 3 head. Okay? This is a 3 head. I can say this one. Okay? This wrong. Okay? This wrong. This is we refer to 3 head. All head means 3 head. Okay? So we refer here is refer to this refer to 3 head, and this is 3 head, and then here is refer to 2 head. Here is refer to 2 head. Okay, and here is refer to 0 head, all tail 0 head, and this refer to 1 head. Here is refer to 1 head. Okay. So if we draw the domain here, let's say I draw the domain here. So let's say I have a sample here, sample space. I have a sample space here. Let's say I have a sample space, and I put this. I have a sample space here. My sample space here is 0, 10. So I have head, head, then I have head, tail. So is it okay? So we just write again. Let's say I have here, we draw the diagram here. So I have head, tail, then I have head and tail. I have here head and tail here. So here I have head and tail. This part I have head and tail. Here I have head and tail. Here I have head and tail. So the sample space here, I have here head, the eta value, head. Then you have head, tail. Then you have head, tail, head. Then you have head, tail, tail. Then you have tail, head, head. Then you have tail, head, tail. Then you have tail, head, and the last one is tail, tail. This is your sample space. The sample space, or zeta here, the element here is named zeta. This is your sample space. This element is equal to the area of each element here is equal to zeta, and we transform or we connect this thing into a real function, a real line. And the real line here is known as a real line, and the element is in the real line here is known as a range. So range, and we have to refer what is the definition of this experiment. This experiment, we define this experiment as a getting ahead. Getting, the outcome is getting ahead. Ahead. So getting ahead, so you have uh, zero head or tail. Here is zero head, zero head. Here is zero head, getting ahead, zero head. So this refers to this part, zero head. And then you have one head, one head, one head. Here is one head. So where is one head? Here is two head, this one head. So this is one head. And this also one head. And this also one head. Okay, one head. Then we have two head. Two head. So here is referred to two head. We have two head here. Here is referred to two head. This is two head. And this thing is referred to also referred to two head. The last one is a three head. Three head. This thing referred to three head. So this thing is known as a random function of x. Okay, random function of x. So this is how we define the what we call the random function of random variables. In other words, is a connection or relationship between domain, and the domain is a domain and the range here. Domain and range. And the relationship between the domain and range is known as a random variable of x. X is a function of random variable there. Okay. So in terms of probability, now I want to find what is a probability just now. So let's say I want to find the probability here. So we go back to the definition just now. The sample space there, or the zeta value, the sample space. So the sample space now, yeah, this is a sample space. This is a sample space here. The sample space value here, I want to connect this thing as in terms of probability. So I just clear this thing off. So I have here the sample space here. I have the sample space, or the zeta value here, is equal to h. Oh, go back again. So I can get okay, wait, we just reverse back, reverse. Okay. I have here head. So I have here the sample space here. I have sample space here. The sample space here can be, the sample space here is equal to head. So we have head. We clear all these things. Okay. So the sample space, let's say I draw it again. So the experiment here, I have here head and tail. So here is head and tail. This part is head and tail. So this is the first, this is the second experiment, second outcome, first. The third one is I have here head and tail. I can have head and tail here. I can have head and tail. Then I can have head and tail. It's the third one. Okay, the sample space here is equal to, here is referred to, this I have here is head and head. So here is equal to head and tail. This part is equal to head tail and head, and this part is equal to head, tail and tail, and this is equal to tail, head and head. This refer to tail, head, tail. This refer to tail, tail and head. And the last one is refer to tail, tail and tail. So my sample space here, and the element in the sample space known as zeta. S here is equal to, so S is equal to the curly bracket here. So H, 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 I have H, H, tail, then you have tail, you have H, H, tail, H, tail, H, H, you have here H, I have here H, tail, tail, H, then you have H, H, tail, tail, then you have tail, H, H. Now you have then tail, H, tail, then you have tail, H, tail, tail, tail and tail, then you have tail, 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 tail and H, tail, H, tail, H, tail, tail, tail and H, sorry, H, H. Tail, tail and H, and then you have tail, tail and tail. Okay, this is a sample space of the zeta value, zeta elements, zeta elements. So now let's say I want to find, we define just now, for all head we define as a x3. So here is x zeta all head is equal to 3, or in other words x all head is equal to 3. So these are all head, 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 head. Then we have x zeta one head, one head. So one head here is one head, one head, one head, one head is equal to 2, and so on and so forth. So never mind. Okay. So let's say I want to find the probability here. I want to find the probability here. So in other words, the number of element here, the number to find the probability, the concept of probability is that the probability is equal to probability of a certain value, probability of x. Let's say probability of x is equal to n of x divided by n of the sample space. This is a concept of probability. So let's say I want to find the probability of when x is equal to probability of x, function of x is equal to 0 head. So ns here, the number of element here, or in other words ns here, ns refer to number of elements is equal to 8. There are 8 outcomes here, 1, 2, 3, 4, 5, 6, 7 and 8. So I want to find x0. 0 means no head, so there is one no head. So n x is equal to 0 divided by ns is equal to 1/8. Okay. So let's say I want to find property of x equal to 1. So mean to say I have one head. So this is one head, and here is one head. So this is equal to 3 over. So in other words, you can write like this. So probability of n and x is equal to 1 over ns. So here is equal to one head, you have 1, 2 and 3, 3 over 8. Now for the let's say I want to find property of 2 head. Let's say I want to find x is equal to 2 head. So here is equal to, you have 2 head, 1, 2, 3, 3 to head, 3 over, or n x is equal to 2 over ns is equal to 2 head, 1, 2 and 3. Wait, 1, 2, 1, 2 and 3. 3 over 8. Now let's say I want to find the other one is probability of, so I have probability of, let's say x is equal to 3 head. So 3 head is n x is equal to 3 over ns. So this is equal to 3 head, 1 over 8. So in other words, we can find the property here, the property of this one, the property of this experiment. Okay. Now, let's say I put here in terms of a function here. So distribution. Okay. So I have a function here. I have x here. So I have x. Here is x of zeta. Okay. And here is a probability of x of zeta. So one head, okay, here is the probability of one head. So I have 0 head, we start with 0 head, 1 head, 2 head, and 3 head. So you cannot have 4 head because of the maximum is 3 head. Okay, and the property here is equal to, so 1 head here is equal to 1 over 8. 0 head is 1 over 8. 1 head is equal to 3 over 8. 2 head is equal to 3 over 8. And 3 head is equal to 1 over 8. And this thing is known as a probability distribution function, or you can put as a probability distribution. Okay, and we have to know that we have to make sure that the total here, this total must equal to summation of summation of p x is equal to put a small x here. Small x here refer to 0, 1, 2, and 3. So must equal to 1. The total here must equal to 1. The total here must equal to 1. This is how we develop the probability distribution. Okay? This is a probability distribution. Now, by definition, the distribution function, the cumulative distribution function. Now, if you just now is the probability function. If you refer to the probability distribution function, these are some properties of a distribution function or cumulative distribution function (CDF). Okay. The first one, okay, fx is px is less or equal than x, and then for x is in between negative infinity to infinity. Okay, and there are several properties here. So you can refer to this part. Okay. So the first one is property of distribution function. Okay. Now, fx in between 0. The first one is fx is in between 0 to 1. Fx x1 must be less or equal than x2. So if x approach to infinity, fx is equal to approach to 1. If fx approach to negative infinity, then fx equal to 0. The limit here must equal to, okay. So look at this, the 4 here, the first 4 here. Okay. Now if I cut here, let's say I cut here, say edit. So let's say I have here the properties here, here. Okay, put here. Okay, the property function here. Now, refer to the property function just now. We have okay, now we have let's say I have here just now I put as a px, I put as a x. So my x here, so this x, then I have px. So sometimes you can put like f small f sub x. You can put like that. So I have 0 head, 1 head, 2 head, and 3 head. Okay. So here is the property there just now is 1/8. Then we have 3/8. Then we have 3/8. The last one is 3 head, 1/8. These are probability function. And then for distribution function, you can put as a capital F sub x. So here is 1/8. Then you have 1/8 plus by 3/8. So you have 1/8 plus by 3/8. You have 4/8. Then 4/8 plus by 3/8. You have 7/8. Then 7/8 plus by 1/8 is 8/8. And this thing is known as a distribution function. So the value of fx here, this fx is in between 0 to 1. 0 to 1, in between 0 to 1. Here is 1/8 up to 8/8. So here, let's say here is x1. x sub 1, here is x sub 2, x sub 3, and here is x sub 4. Fx1, this one, must equal to, sorry, this one, fx1, these are f capital F sub x, x1, is less than f sub x2, fx sub x, x2. This thing must be less than this thing. Okay? 1/8 less than 4/8. Okay. Then if x approach to infinity, okay, if x approach to infinity, outside here x approach to, so here is here is this part is negative infinity, and this part is a approach to positive infinity. Okay. So if we approach to negative infinity, fx equal to 0. Then if approach to infinity is up to the maximum here, this approach to fx approach to infinity, this is equal to 1. Okay? This is equal to 1. Okay. This is how we define there are several properties here. How we define the properties of distribution function. Distribution, the properties of distribution function. Okay. Now, the property function can be divided into two. So we go to discrete random variable. So the property function can be divided by 2. Okay, now I have the property function can be divided by 2. The can have property function, probability function, okay. So you can divide the two, discrete property function, and the other one you have the continuous property function. So you have discrete and discrete involving to find the thing you have to sum here. You have to do a summation here. This is a whole number. We refer to whole number. There is no rational number. This is a whole number. This is a whole number. This is referred to a whole number. And here it can be a rational, can be a ratio, can be a ratio, can be a ratio, can be a ratio, can be one. Okay? There is a can be a it's a in terms of interval, can be in terms of interval. It's continuous. Okay? So property function is we have discrete and continuous. Okay? So for this discrete, and for discrete to solve, we always use symbol of summation, and here we always use a symbol of integration. Integration and summation. Okay. Okay. There are several properties of discrete property mass function or discrete property functions. The the properties here, the properties of the properties of properties of a mass water property function. Okay. Mass refer to a discrete variable, discrete random variable. So if you have the mass density, if you have continuous, we refer to density. Okay, now the property for the first property here is I cut here. Let's say I cut here. I put here control B here. Okay. I cut here. Put this way. Control C here. So I put here. Okay, and I have here. Okay. Okay, I have here. Okay. Now the properties here, the first properties, the property here must equal to between 0 and 1 for k is equal to 1 to k is equal to 1 to infinity. Is k equal to 1 to infinity. Now then property of x is equal to, if x is not equal to k, any value here is not equal to k is equal to 0, okay, then summation here, like I told just now, the property of the summation here is must equal to 1. Okay? Must equal to 1. These are properties of discrete property. Let's say I have here, just now, okay, I have x of zeta here, just now, of experiment of tossing a coin here, x, so I have x is equal to 0, 0 head, 1 head, 2 head, and 3 head. The probability just now is I put here is that px, this is refer to discrete, because you have 0, 1, 2, and 3. So I have here is just now is 1 over 8. Then you have 3 over 8. And then you have 3 over 8 because you get there are 3 head, 2 heads, and 3 heads is equal to, that's 1 3 head, 1 over 8. Now x, the probability here, this is a probability, of x equal to 0. This is a probability of x equal to 1. Then this is the probability of x is equal to 2, and this is the probability of x is equal to 3. Okay. Now the property of the value here is between 0 to 1. We do not have 0 1 here, between greater than 0, so we have 1 over 8 and 3 over 8. The maximum value is 3 over 8. So px is equal to 0 if x is not equal to k. So our k here is a k1, is a 1, 1, 2, 3, k is equal to 1, 2, 3. So if the value of x here outside this range, the probability there is equal to 0. So if I have here like this, I have a graph here. Here is your x, and here's the px. So here is 1 over 8, 3 over 8, 3 over 8, 1 over 8. Outside of this range is equal to 0. So our range here is between 0 to 3, and 0 to 3. Outside of this range is equal to 0. Okay? Nothing to do with this one. Okay? So outside of this range is equal to, outside of this range is equal to, the rest is equal to 0. So that's why if x is not to sk, we define sk is equal to 1, 2, 3, and 4 here. We don't have this, and then s is equal to 0. And summation of px sk, this summation, okay, this thing, the summation of this one, this summation of p sub x, x sub k, the total here is equal to 1. So if you add all these things, is equal to 1. Okay, is equal to 1. These are the properties of positive function. Okay, I think that's all for today. So you can do an exercise by referring to. Okay, you can try to solve a few questions here. Yeah, and the Bible. Okay, please try this question. Try to solve this one. Okay, please try to solve. There are a few questions here, so you can try this question 2.1, 2.2. Okay, you can refer to that question 2.1, 2.2. Then you can also solve 2.3. 2.3 don't solve. Okay, you can try 2.1, 2.2, and 2.3. Okay, 2.1, 2.2, 2.3, and then you can try to solve 2.8. Okay, try to solve 2.1, 2.2, 2.3, and then try to solve 2.8. Okay, 2.8. So you have 4 questions here. Try to solve. You don't have to send to me, just for the exercises. Okay, for the exercises, try to solve 2.1, 2.2, 2.3, and 2.8. Okay, that's all for today's lecture. So I will upload these notes or this lecture in YouTube. Then you can refer to the lecture. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.